Hey guys, hopefully I will finish off the Philco 60MB finally in this video. I finished removing all the corrosion a second time around, and I scrubbed down the chassis really good. I used some of your suggestions like isopropyl alcohol, and then I went over it with a nice healthy dose of the Bowie Shield, or Bow Shield. I guess it's from Boeing, so it'd be Bow Shield T9. And it's still looking really good after a few hours. Hope that holds up. Now, one of my astute viewers noticed something about this tuning capacitor. If you recall, I had been puzzled as to how the heck you're supposed to adjust the oscillator and antenna trimmers when the screw heads are on the underside. Well, check it out. There are slots cut into the ends of the screws, so you can indeed adjust them from the top. So that will be great, so I can proceed with the alignment. Before I do that, though, there's one thing, well, two things left I need to do. One is mount the dial lamp. I've been trying to clean it up. I think this is silver plated, and that black is all tarnish. Now, silver oxide is conductive, so I don't think I need to go too nuts with cleaning that up. It just looks a little grungy, but it should work all right. That mounts something like over here. I'm not sure about the dial pointer, though. Maybe this just doesn't have one. I know the original tuning cap that was on here had one. Here's what I'm talking about. So, in addition to the dial lamp, there's also a pointer that mounts on the front. This doesn't have one. Not critical. The tuning window opening on the front of the radio, the bezel, it's fairly small, so when the back light goes to the dial, you can see the numbers, so not too worried about that. And one last thing is the grid cap that goes on this tube. The wire was kind of frayed, so I want to replace that. And then that should be it for the chassis restoration. Alright, here it is the next day, and there's some discoloration on the steel, but it's not bad. I can certainly live with that. I've reinstalled all the tubes, tube shields. I was able to transplant the pointer from the other tuning cap, and I got the dial scale on there and the dial lamp mounted. It all seems to be working alright. I don't know what station this is. I didn't expect to hear XTC on AM radio.
Life and death decisions concerning people they never met.
Alright, so that leaves one last task, which is doing alignment. So I've printed out what I think are the correct instructions. There were numerous revisions of this chassis. This one's old enough that there's no wave trap, so I think this is right. The main difference between them is this trimmer. On this diagram I showed as being the low frequency police band, but on other revisions it has an entirely different purpose, so we'll give it a shot and see what happens. And here are the instructions. So, the conventional way to do this, at least for the IF, is you pop the cap off the 6A7 pentagrid converter, you feed in a signal from an RF generator, something like this, and you connect your meter across the primary of the output transformer, and you peak it. So, these ones that say 460 here, 460 kilocycles is the IF frequency, so you'd peak 1, 2, 3. Well, what I want to try doing is use this beast, which is an RF generator, but it's a digital synthesized, so you can type in like 46000 and get exactly 460 kilocycles or kilohertz. Very, very clean, pure sine wave. So I could do that, but what I want to try doing is to use a sweep. So sweep it from let's say like 440 to 480, like 20 kilohertz on either side of the IF, and do it with the scope. So on the scope, what I hope to see is flat, and then a bit of a peak, and then flat. And I'll put a marker right at 460, and I will tweak each of those trimmers to get that peak to be as high as possible. And symmetrical, if that even has any impact on this radio. It doesn't exactly have the widest bandwidth, but we'll see. Now, the main challenge for me is I have not used this before in this application, and it's big, and I got to make a bunch of connections between this and my scope. Some on the front, some on the back. So at least all the connections will be on the front of the scope. X, Y, and Z, which I don't think I've ever shown before. The Z input. On this, the Z output's in the back, and I think the X is on the back as well, but the Y, in other words the RF output's on the front. Maybe if I rotate this 90 degrees and put it like right below my scope, my 3-foot long BNC cables will reach, something like that. I'd like to slide it underneath my scope, but then I will have a very hard time reaching the connections on the back. Anyways, I'll figure something out. Now, the reason I use the Z-axis is, well, I guess they call it a new and improved way to do markers. You may have seen markers on my older videos or other people's videos or photos. You see a little, what they call a birdie marker. So you'll see your little curve, and wherever your marker is, you see a little blippy thing indicating the marker. What that is it's like a super heterodyne between your marker generator and the sweep generator. When the two frequencies coincide, they reinforce each other and it makes a little blip. Well, that can cause some problems. One is the actual marker signal can distort the response curve. And two, the markers typically are in the vertical axis, and if you want to do a marker on, say, the rise or fall of a response, it can be pretty hard to see. So what this does is they modulate the Z such that right where you hit the marker, the Z goes from low to high. What the Z-axis does is it modulates the intensity, the brilliance of the trace on the scope. So imagine we're sweeping 440 to 480. As we approach 440 to 460, it'll be kind of a dim trace, and then right at 460 it'll get brighter and stay brighter for the remainder of the trace. So right at that point where it goes from dim to bright, that's your marker. Have not ever tried using this before, so I'm curious to see how it works out. Alright, I think I got the hang of this. So what we see on my scope right now is the RF output and the X-axis drive. So if I turn this down so we can see sine wave, that's my RF output. I dialed in to do a sweep between 440 kilohertz and 480, so it's not changing much. That's why it's just barely wobbling. If you're not that familiar with sweep generators, this is exactly the same as you taking your RF generator and going like this. That's all this is doing. What you see on this axis is a drive that you put to your oscilloscope. So when you use a sweep generator, you do not use it in this mode. This is just a convenient way to see what the output signals of this thing look like. What you use it in is XY mode. So, it's my X-axis, stretch it out a little bit. And there is my Y-axis. You can set the refresh rate, or rather the sweep rate on this. Right now I've got it going at 0.05 seconds. Let's see if we can speed Speed that up a little. I guess this is the fastest you can possibly go. So display looks a little less crazy now. Now again, you would not use it like this either. You would not feed the RF or IF frequency right into your scope. You put the output of the detector into your scope. So instead of seeing all this, if I put this into something with a really wide bandwidth, it was flat response throughout the sweep range, you would just see a straight horizontal line. That's it. But because this is a tuned circuit, we should see something like that. Now, next thing I want to try is hooking up this Z-axis, and if I type in the marker, we should, if this is working right about in the middle here, it should get brighter on this side. Well, unfortunately, now I've got another problem. This Z input is not intensity modulation. It's strictly blanking. It's either all or nothing on the display. So when I hook this up, it blanks out half of it. Now, I can still use this because I've set my scope up such that 460 is exactly on this axis. And by setting my stop and start frequencies and adjusting the width, I can get it so that each tick mark is, say, 1 kilohertz or 5 kilohertz or 10 kilohertz, whatever, and then I can just read it right off the scale, and I don't need markers at all. So if I can't get this to work any other way, I'll just do it like that. I know that 460 is dead center, so that's that. Now, another possibility is I can fall back to my trusty old Tech 465. I just need to check to see if this can do XY mode with intensity modulation. I already know I can do XY. This is the X and this is the Y, but I don't know about intensity. I don't see any jacks for it on the front, but there might be one on the back. Alright, it's definitely going to work with the 465. So right now I just have that sawtooth X-axis and the Z-axis attached to the back, and you can see how the trace gets brighter halfway through the sweep. Alright, I hooked it up to the radio finally. What I did was I popped the cap off the 6A7 and hooked up a separate cap with just a little short lead coming out, and that's where I'm feeding my RF in. That's what the alignment instructions say. That's what they're referring to by removing the grid clip and hooking the signal generator to the control grid. The control grid is that top cap. Alright, so when I sweep it, I am not getting what I expected. That's 460. That is where the peak should be. We got a peak over here. And as far as this wavering goes and that buzzing you hear, the fastest you can sweep this generator is 100 hertz. So it sweeps 100 times a second. That's what we're hearing. 100 hertz signal, and that's where this wobbliness is coming from, I believe. So just ignore that. So my first thought was, there's something not right with this generator. So I fired up this guy, and I'm feeding that in with a capacitor to the same point, so this is serving as a marker generator. So if I crank this up and tweak this dial, when the frequencies coincide, I should see a bit of a blip, and there it is. I got the level way too high. That's what I meant about when you use this type of method for marker generation. You can distort your response curve because of this, unless you get post-marker injection, which is far better. Injecting the mixer and the sweep at the same point distorts it, but what it tells me is whatever frequency I read off the dial is the frequency I got right here, and it's definitely not 460. That little black triangle there, that's 455, and the next tick to the right of that is 460. So this is actually peaked at about 480 right now. So that sure isn't right. But it also tells you that this setup does seem to work. The picture's not as pretty as I was hoping it would be, but I'm still kind of learning the ins and outs. of using all this equipment together. So let's see if we can get this peak shifted over to the left and get that amplitude any higher. Now Philco recommends you use a special fiber hex wrench that they came up with. By fiber I mean it wasn't metal, so A, it wouldn't short anything out, and B, it wouldn't add any inductance or capacitance. Well, my poor man's solution to that is wrap some electrical tape around a 1/4 inch hex nut driver. You got to fit it in over these, and if it's anything like the other 60 chassis I aligned, some of these caps are hot, and if this was metal on metal, go into that cap and you touch the side like that game Operation, you short out the power supply. Alright, so the first one they say to do is number 1, which, assuming this is the bottom view, is on the far left. So that, I believe, is the closest to the output. So I think the idea is you work your way back towards the front end as you go left to right. So, get that on there like that. So you can definitely decrease the amplitude. It's going to be a little weird to shift it over to the left, because if these are all peaked off frequency, I'm probably going to have to go through multiple passes on these 3 IF trimmers. Alright, we're starting to get it over to the left now. So I will just keep going back between these 3 again and again and again. Try to get that peak exactly where it goes from dim to bright. I'm going to tweak this a bit so. Like I had it before, right on that axis, that's where the peak should be. Oh, and as for this being kind of messy, so the jumping around is because of the sweep generator, but if you're wondering why this is so wide, that's actually the carrier frequency. I don't know if it's a limitation of this design or I've got some RF leaking through, but that is unrectified RF. So that's like 460 kilocycle sine wave imposed on the response curve. So I'm going to switch to using a detector probe. This has like a germanium diode inside of it, and it will rectify and clean up this. That is much better. Not only did this detector clean up the RF noise, but I didn't have it grounded very well, so now the jumpiness is gone as well. So that's what I've been hoping to see all this time. And now I just got to make it look better. So I'm getting close. Just got to shift this peak over a little bit to the left. Certainly a more interesting way to do an alignment, I think. So whereas you would normally watch a VTM needle swing around, what you've got to do is just keep your eye focused right on this line, ignore anything else, and just get that point to be as high as it can be. Forget about the shape of the waveform and all that. So like that, obviously we got a better peak when we do that, but we just care about this line right here. So actually right about there is right for that trimmer. This, which would be the most sensitive, so now I'm the closest to the beginning of the IF strip, and there we go. Not exactly symmetrical though, so I'm going to go back to trimmer number 1. So you might think, oh, that looks better and it's a higher peak, but that's not on frequency. It needs to be a little further to the left, so actually, not like that. Well, I've actually gone too far, so I got to work back the other way, but almost there. Alright, I not only spent more time tweaking those trimmer caps, but I also played around a bit with the settings on my scope and the sweep generator to make that IF response curve even more visible, and I also turned off the lights in my workshop. As you can see, I've now got it peaked right on the axis, and that transition from dim to bright, and it is pretty darn symmetrical. So I think that's it for the IF alignment. I'm going to disconnect my equipment now and fire up the radio and try to tune in some stations, see if it sounds any better. Okay, I disconnected and shut down all the test equipment. I've got an antenna hooked up that's about 4 feet long and just going up straight. Just starting at the high end of the dial here on the AM broadcast band. Did the best I could with the HF and LF oscillator trimmers to get the dial pointer to line up, and it's not off too much on the stations I recognize, but it's not perfect. Sounds pretty good. Oh, and I'm picking up plenty of stations too, so the sensitivity is pretty darn good. This is my own transmitter, my SS Tran, that is about 40 feet away, I'd say.
And there's no stopping us right now. I feel so close to you right now.
So I'd say this alignment is definitely successful. Don't know if I'll use that technique all the time going forward, because it's obviously a bit of work to hook up the scope and all this stuff versus just an RF generator. But it's definitely an interesting process to go through.
As a child, you know, on particular days, or who has a child in their possession at a particular time, it is primarily about
doubts the Word of God naturally begins to move. It's time to make some noise.
So go lower and lower now. I'm going to start getting into more of the big powerful stations like AM 1000, AM 720. It should be WLS, which should be 870. So it's pretty good as far as the dial being lined up. This should be 840, so you can see it's starting to get more and more off. Let's see where AM 720 ends up.
They do to manage my health care better.
I'm not sure what that is.
I avoided a stroke. It's a combination
Try
of
780.
expertise and compassion.
This is GM. Okay, so GM's pretty good. Should be 720, which is pretty much dead on. This is 670, so that should be more like over here. Let's see where 560 ended up. Yes, 560 should be over here, but I'm picking it up over here. But all things considered, I'm not too worried about that. So shortwave. Let's see, it's about 6:30 in the evening now, so I'm not sure what I'll be able to pick up. The time station I got in the earlier video should be somewhere around here. But when I did that one, it was more like 2 in the morning, not the early evening. Well, I'll try the shortwave again later tonight and see what I get. In the meantime, I'm going to finally mount those 2 caps and pull out that other speaker and see about doing a recount on it.